Today we will solve LeetCode problem number 451, and it's sorting the characters of a string by frequency of occurrence in that string. And this has been asked quite a few times in interviews of Google, Microsoft, and Uber, and even LinkedIn. So let's see how we will approach this problem. So let's say you are given this string. So you see that A occurs 3 times or 2 times here. So A occurs twice. B occurs just once, C occurs 3 times, and D occurs once. So C is the most frequent character. So you will write C, C, C. C occurs 3 times, followed by A, since next one is A, its occurrence is twice, A, A. Then B and D are occurring equally. So in this case, either you can put B, D, or you can put D, B. Both of these answers will be accepted. So what approach we can take is, we can start iterating the characters of this array, and let's store it in counts. And we can have a map, which will be character and the corresponding count. So once we iterate, we check if it's present in the count or not. If it's present, we increment its count. If it's not present, then we insert it with a count of 1. So first A occurs. So in this map, A will be inserted with a count of 1. Then C occurs. So C is inserted with a count of 1. Then again A is here. So this becomes 2. Then B. Again C, so it becomes 2, then D, then C, so it becomes 3. So this is the final counts map. After that, what we will do, we need to sort it. Just storing in the map is not enough. We need to sort it on the basis of their counts. So this second entry should come first, followed by this one, then either of these. So we can store these pairs in some linear structure like a vector or a list. So let's say I store these in a vector. Let's call it countVec. And in order to sort, this sort function takes a linear data structure like vector or list, and it also needs a comparator. By default, it will be some inbuilt comparison like less than or greater than, where the values are directly comparable if you don't provide a comparator. But let's say you need some custom sorting. For example, in this case, these are key value pairs, and we want to sort them on the basis of the values, not keys. And also we need to sort them in descending order. That is, C should come first, followed by this. So you can see that here we need custom sorting. So we need to provide a comparator. So why do we need a comparator? Because in order to sort, let's say you want to make people stand in a queue such that shorter people in height stand in the front and the taller people stand behind them, and the tallest will be at the end. If 2 people are of same height, they can stand anywhere. So here we have a notion of comparison. We can compare 2 heights. If we are given 2 heights, we can compare whether h1 is less than h2 or h1 is greater than h2 or h1 is equal to h2. So the quantities need to be comparable, like greater. There should be notion of one quantity being greater than other. And here we need it in custom fashion, based on value and in descending order. So we will provide a comparator for this. First, we will put everything in count vector, where each element will be one pair key value. C3, B1, and D1. So now this is the vector, and we will sort it. Sort countVec. Now what will be the state of this vector? It will be C3 followed by A2 followed by B1 followed by D1. These two can again be interchanged without making any difference. And once we have this sorted count vector based on the counts, we can iterate it. So take the first entry here and its value, take the value, take the key. This is the character. This is the frequency. So for we can have a result, empty result. And what we will do, we will see what is the frequency 3 and what is the character C. So we will append this C 3 times to this result. So result will become C, C, C. Now we will take the next element. Next character is A and its frequency is 2. So we will append A twice. Next is B and once. So B and D. And we will return this result. So let's see the implementation of this in C++, Java and Python. And they have clearly mentioned that if this is the example tree, so EERT, since E occurs twice, R and T occurs once, this is the output. And they have said that EETR is also a valid answer, since there is E, R and T are both equal, so you can output them in any order. So we need an unordered map here first to keep track of the count. Now we have this counts map. So we will now sort them. So let's first put them in a vector, and the elements of vector will be a pair of char and int. And let's call it count vec, counts.begin, counts.end. So it will create a vector for all the entries of this map from begin till end. So each element will be a pair. And then we will sort them using the std sort function. Count vec dot begin, count vec dot end, and the third parameter is the comparator. So here the two elements to compare are pairs, and we will compare them based on their values. So pair char int p1 and we are doing greater because we are printing first the highest values. So second denotes the count and first denotes the character. So let's try. So it works for this example. Let's take the second one. And our answer matches with the expected one. So let's go ahead and submit. And the solution is accepted in C++. And it took around 40 milliseconds. This can vary for your case. For 35 test cases, these numbers I have seen fluctuate quite a bit. And you are here, so we are roughly better than 40%. And these numbers vary sometimes, so you can try a few times. So let's go back. And now we will submit it in Java. So let's copy it. So we will use the same logic everywhere. The thing is that data structures will keep changing. And this problem is more of a data structure knowledge rather than logic, since the logic is very clear here. And the map will be character and integer, just like C++. Counts equal to new hash map. Counts dot put C counts dot get C. So whatever is the count, get it, increment it by 1. But there is a catch here that this C may not be present. So key may not be present here. So for that, there is another version of get for hash map here, that get it. If it's present, then get the actual value. If it's not present, use a default value. So it's called get or default. If you are certain that this value exists, then you can use get. If you are not certain, then use get or default. And if it's not present, take 0. So add 1 to it. So it will become 1 this term if the key is being inserted for first time. And that is what we want. So now counts has been created, this map. Now we will create a linear structure just like C++ case. Here we will create a list map.entry. Here we were taking pairs and each entry in the map was a pair. Here its type will be map.entry. And it will be this character integer. Next, we will use this sorting thing. And again, we are providing a comparator. And if you want them in ascending, you will write a.getValue minus b.getValue. And this should sort the list. So we have exactly replicated the C++ logic. And it works as expected. So let's submit. And the solution is accepted in Java as well. Finally, we will do it in C++. Sorry, Python 3. So get C in the counts, else 0, and add 1 to it. So we will sort it and we will call it counts sorted. Sorted function we will use, and counts dot items, and we will specify reverse equal to true, and then we will use the lambda function. And we will sort them on the basis of C1. So here 1 means the second value. If this would have this counts had 3 values for each element, and we wanted to sort them based on third element, we would have C2. And if based on first element, C0. So here we have just key and value, we will use C1. And now this is sorted in descending order based on their counts, which are in C1, the second element. And next, we will return a result. So here result equal to, we will join to it C0. C0 is the first character. So the loop will be for C in counts sorted. So C is looping. C denotes one element of this count sorted, which are key and value, character and their counts. So for each of the C, do C0. C0 is the character, and then we use this multiplication C1. So this means repeat this C1 times. And this is the result. And we will finally return the result. So just for some clarity, let's print here counts sorted so that you get an idea what this denotes. So you see it denotes that E has occurred twice. Similarly, in the second example, B has occurred 4 times, A has occurred twice, C has occurred once. So each element has 2 elements, key value pair. So here C0 is, in this case, B, and C1 is 4 for the first element. Similarly, next C will take the value of A, and when we multiply it, we repeat that so many times. Now let's submit. And the solution is accepted in Python as well. And it again takes similar amount of time, 48 milliseconds.